Hello everyone, welcome to my new lecture. Today we are going to start exercise 8.1 from geometry of straight lines. Okay, starting with the first question, we are given the value of our inclination, which is our angle, as 0, and we need to find its gradient. Gradient can also be referred to as slope. We know that m is equal to tangent theta, which means that the gradient is equal to the tangent of an inclination. Here the inclination is given as 0. So we can write gradient is equal to the tangent of 0, and the tangent of 0 is just 0. So our gradient will be 0. In the second part, the inclination is given as 30 degrees. So again we will use the same formula, which is m is equal to tangent of 30 degree is 0.57. So our gradient will be 0.57. At the third part, we are given the inclination as 60 degrees. So we can write m is equal to tangent of theta, m is equal to tangent of 60. So by finding out the tangent of 60, we get m as under root 3. And in the fourth part, we have theta as 90 degrees and we need to find the value of n. So if we take the tangent of 90, that will be undefined. That means that our gradient is undefined. Moving on to the second question, the first part here, it's the opposite of the first question. We are given the value of our gradient as 0 and we need to find the value of the inclination. We know that m is equal to tangent of theta. Here, place the value of m as 0. 0 is equal to tangent of theta. So in order to find the value of theta, we will take the inverse, the tan inverse of this gradient. So we can write theta is equal to the tan inverse of 0. So our theta is also 0 degrees. Now in the second part, here our m is equal to 0.57. So we are again going to use m is equal to tangent of theta, where m is 0.57. And by taking the tan inverse of 0.57, we get the value of theta, our inclination, as 30 degrees. In the fourth part, here the value of m is given as negative 0.364. So what will happen now? We will take the tan inverse of negative 0.364. So that is negative 20. But we know that degrees can't be negative. So we will subtract this value from 180. That means 180 minus 20 degrees will be our new inclination. So that is 160 degrees. If you look at the fourth part, you will notice that here we have negative 1.732. That is our gradient. So we will take the tan inverse of this, and that is negative 60. But we also know that our degree can't be negative. So 180 will be subtracted from this value. So we get 120 degrees. That will be our value of theta. Moving on to the third question, here in the first part we are given 2 points, A which is 2 comma 6 and B which is 5 comma 8. We need to find their gradient. So in the first two questions we were using the formula of m is equal to tangent of theta, but m is also equal to y2 minus y1 divided by x2 minus x1, or in short, vertical distance divided by horizontal distance. Here in the 2 points, the value of y2 is given as 8 while y1 is given as 6. So we can write 8 minus 6 divided by 5 minus 2, which is x2 minus x1. So we get 2 by 3. So our value of our slope or gradient is 2 by 3. Now we want to find the inclination. Then again we are going to use the formula that we just applied in the first two questions, which was m is equal to tangent theta. Here we will take the tan inverse of 2 by 3, which is our gradient. So our inclination is 33 degrees. Moving on to the second part, here we have 2 points, which is C negative 2 comma 4 and D which is 1 comma negative 3. So what will happen? We will again use the same formula of slope, which is y2 minus y1 divided by x2 minus x1. Placing the values of y2 minus y1, we get minus 3 subtracted from 4 divided by 1 subtracted from negative 2. So that is negative 7 by 3. That is our gradient. Now using the formula of m is equal to tangent theta, we need to find the value of our inclination. So we can write tan inverse of negative 7 by 3, that is negative 66. But this will not be our inclination because our degree can't be negative. So 180 will be subtracted from 66 and 114 is our answer. Moving on to the third part, here we have points E 5 comma negative 2 and F which is negative 2 comma 3. So we know that gradient is equal to y2 minus y1 divided by x2 minus x1. We can write minus 3 subtracted from negative 2 divided by minus 2 subtracted from 5, and in short that is negative 1 divided by negative 7. So negative and negative get cancelled, our gradient is 1 by 7. Now applying the formula, we know that tan inverse of our gradient 1 by 7, that will be our theta. So that is 8.13 or 8 degrees, that is the value of our inclination. Moving on to question number 4, here we are given 2 points which is A and B with coordinates negative 2 comma 6 and 7 comma negative 3. So for the first case, these both points, a line is passing through them and that line is parallel to these both points. So we must know that if we have two lines or a line which is parallel and it is passing through our points, so the gradient will be equal. That means m1 will be equal to m2. But if it is perpendicular, that line, we have two lines and they are intersecting to each other, which means they are perpendicular. So our formula of gradient will be m1 into m2, that will be equal to negative 1. So for the first case, we will just normally use the formula of gradient y2 minus y1 divided by x2 minus x1. So here we have negative 3 subtracted from 6 divided by 7 subtracted from negative 2. That is negative 9 over 9. Divide them up, we get negative 1. So we can write m is equal to tangent of theta. The tan inverse of negative 1 is negative 45. So 180 is subtracted from 45. We get 135 degree. So this is our gradient and that is our inclination. But for the second part, here that is perpendicular. That means that the gradient that we just found, negative 1, it will now not be equal to m1 and m2. That means now the gradient of m1 and m2 is changed. We will use the formula of m1 into m2 being equal to negative 1. Apply the value of m1 which is negative 1. So negative 1 gets cancelled on both of the sides. That means our second gradient is 1. Okay, so for the first case, if our line is parallel and it is passing through both of these points, then our gradient will be negative 1, which means m1 is equal to m2. But for the second case, if they are perpendicular, that means they are intersecting, then our gradient will not be equal. m1 into m2 will be equal to negative 1. Okay, let's move on to question number 5. Here we are given 2 points 3 comma x and 5 comma 8 and the gradient which is 4. But we need to find the unknown value which is x. So again we are going to use the formula of gradient y2 minus y1 divided by x2 minus x1. So that is 8 minus x divided by 5 minus 3. But we know that the value of gradient is given as 4. So we can say that 8 minus x divided by 5 minus 3 is equal to the value of 4. Now if we cross multiply, that means that 5 minus 3, that is 2. So 4 2s are 8. 8 minus x will be equal to 8. Now there is a negative sign alongside x. So we will move x to the right side while 8 will move to the left side. So that means 8 subtracted from 8 is 0 and that will be equal to the value of x. Moving on to question number 6. Here we have 4 coordinates a k comma 2, b 3 comma 5, c 5 comma negative 1 and d 8 comma 7. So first we need to find the gradient of the points. We need to find the gradient of a and b and then c and d. And we need to check whether they are parallel with each other, as in the question it is provided that they are parallel, and need to find the unknown value which is k. So first we will find the gradient of the first 2 points a and b. We can write 5 minus 2 divided by 3 minus k, and that is equal to 3 divided by 3 minus k. For the second gradient which is of c and d, we will write 7 subtracted from negative 1 divided by 8 minus 5, and that is 8 by 3. Now we know that they are parallel with each other. when we have 2 points or two lines that are parallel to each other, then the gradient will also be equal, which means m1 will be equal to m2. So we will write the first gradient, let that be equal to the second gradient. So now we can cross multiply. We can write 3 into 3, which is 9, and 8 will be multiplied with 3 minus k. So we get 9 that is equal to 24 minus 8k. So the minus 8k will go to the left while 9 will go to the right. So 24 subtracted from 9, that is 15. Divide that by 8 on both sides. So we get the value of k as 1.875. So that is how you find the value of k. Okay, in question number 7, here we are given the points P, Q, R, S, and in the question it is provided that these points are perpendicular to each other. So if you look at P and Q, we are going to find their gradient. We have negative 1 comma 2, and in Q we have 4 comma 7. So finding the gradient of M1, that will be y2 minus y1 divided by x2 minus x1. We can write 7 minus 2 divided by 4 minus bracket minus 1, that is 5 by 5 or simply 1. And in the second gradient of RNS, we have 10 minus k divided by 7 minus 2, so that is 10 minus k divided by 5. Now we found the gradients of PQ and RS, and in the question it is provided that they are perpendicular. So when we have 2 points or two lines that are perpendicular, their slopes will not be equal. Instead, we will take the product of their slopes, and that will be equal to negative 1. So this is our formula basically. So we can write 10 minus k over 5, which is m1, and that will be multiplied with m2, which is just 1, and that is equal to negative 1. So if we cross multiply, we get 10 minus k being equal to negative 5. So 10 plus 5 is 15. That means that the value of k is 15. That is the value of the unknown. Moving on to question number 8. Here we have points which are 3 points x, y and z. We need to check whether they are collinear. So we can check whether they are collinear by using the distance formula, and we can check by using the slope formula. So in the question it is provided that we need to check whether they are collinear or not. That means they lie on a straight line. So we will use the formula of slope. Here we will take the gradient of x and y, that will be 7 subtracted from negative 3 divided by 4 subtracted from 0. So that is 10 divided by 4 or 5 divided by 2. For the second gradient, which is of y and z, we will write 12 minus 7 divided by 6 minus 4, and that is also equal to 5 by 2. And for the last gradient, which will be of x and z, or in short the first and last point, we can write 12 minus bracket minus 3 divided by 6 minus 0, that is equal to 15 by 6 or 5 by 2. So we can conclude that all are equal, hence the points are collinear. Moving on to question number 9. Here we are given points P, Q and R. Firstly, we need to find their gradients. Finding the gradient of PQ, that will be 2 minus y divided by 5 minus 4, and we know that it will simply be 2 minus y divided by 1. In the second gradient, which will be of Q and R, we will write 2y plus 1 divided by 6 minus 5, and that will be equal to 2y plus 1 only. And for M3, we have 2y plus 1 minus y divided by 6 minus 4, so that is y plus 1 divided by 2. So we need to basically find the value of y. We know that in the question provided, all of these points, they are parallel to each other, which means that their slope will be equal. So we can say that the slope of m1 and m2 will be equal. So we are going to write 2 minus y, which is the slope of the first 2 points, and that will be equal to the slope of the second 2 points, which is 2 minus y is equal to 2y plus 1. So 2 minus 1 will be equal to 2y plus y. So y will be 1 by 3. That is our answer. Okay, moving on to question number 10, which is the last question of this exercise. We have a parallelogram with coordinates a, b, c and d, and a is negative 2 comma 1, b is 6 comma 3, c is 10 comma 5, and d is 2 comma 3. So we need to find the slope of all of these sides and see whether they are the coordinates of a parallelogram. In order to do that, we will find the slope of AB, which is M1, then DC, which is M3. And we will check whether M1 is equal to M3. Then we will find the slope of BC and AC, AD, which will be M2 being equal to M4. So if they are equal, that means opposite sides are equal to each other, then we can conclude that this or they are the coordinates of a parallelogram. So by using the formula of gradient, we can write y2 minus y1 divided by x2 minus x1, and that will be equal to 3 minus 1 divided by 6 minus bracket minus 2. We are finding the gradient of the 2 points AB first. So that is 2 by 8 or simply 1 by 4. Now if we find the gradient of DC, which is M3, we will notice that 5 minus 3 divided by 10 minus 2, that is also 2 by 8 or simplified 1 by 4. So far M1 is equal to M3, but we need to check whether M2, which is BC, and M4 AD, that is also equal with each other. So m2 y2 minus y1 divided by x2 minus x1, that is equal to 5 minus 3 divided by 10 minus 6. So that is 2 by 4 or simplified 1 by 2. And for AD, which is m4, that is 3 minus 1 divided by 2 minus bracket minus 2, or 2 by 4 simplified 1 by 2. Hence proved they are the vertices of a parallelogram, as the opposite sides, the slopes of opposite sides are equal with each other. I hope you guys liked my lecture. If you did, make sure to subscribe to my channel and share this video with your friends and family so they can benefit from it. Thank you.